So, I'm Freddy. For those who don't know me, I'm going to show you and tell you about the SatNOGS project and how we hunt satellites with open source tools. But first, let me do a quick introduction about the LibreSpace Foundation, which is the one that supports SatNOGS project. So it's LibreSpace Foundation, also known as LSF. It's a non-profit foundation founded in 2015 in Greece, and what we do is to create space technologies only, and we are trying to do everything open source, and also use an open source toolset if possible. We have several projects in LibreSpace Foundation. The first one that actually initiated the LibreSpace Foundation, and the most popular it's the SatNOGS project. So what is SatNOGS? How it started? It started through a NASA Space Out Challenge hackathon, and what we tried to solve, one of the challenge was to track deployment of satellites. So the SatNOGS has and had as a goal to build a network and to automate all the processes for tracking and communicating with satellites. Today, actually, it's SatNOGS is an open source stack of software, hardware projects, services, online services, and also open collection of data. And we have several contributors around the world, universities, organizations, space agencies, satellite teams, the radio amateur community, scientists, engineers, researchers, space enthusiasts, and other individuals. What we do? Actually, we are doing ground segment operations, including receiving telemetry and also developing telecommand control capabilities for VHF, UHF, L-band, and S-band. And also we try to visualize this telemetry. We also maintain a collection of observation artifacts, which is data from satellites, spectrograms, audio files, IQ data in some cases, and some optical artifacts. Another thing we do is to determine orbit of satellites and also generate our own orbital data. And also we do satellite identification, which is the process when a satellite is deployed, when actually many satellites are deployed, the radar of NORAD shows some objects. But usually when the satellites are on the same size, you don't know which one is your satellite. So what we do is to identify that this object that radar sees is this satellite. This is not always successful because it needs the satellite to be operational, but in most cases we can determine which one it is. And finally, we also record frequency violations, especially during especially on the radio bands. Also, for some who gets involved with the projects, there are several educational opportunities, like learn some fundamental stuff about satellites, communication and orbital analysis. Also, people that want to go a step further and help in development and stuff can build skills around software, hardware, and also learn open source tools that we use. So, here are some issues we have seen during the last years in satellite missions. So, there, especially for new satellite operators and new entities that deploy satellites. Usually, in ground segment, you have ground stations that don't work or are broken during the launch or later. Another problem is that in some cases the orbit of the satellite is not doesn't offer many good passes over the ground segment of the satellite team. In space segment, we have seen failed signal transmissions, or the satellite randomly transmit during its orbit, or transmit only in sunlight, or in the first hours or days after deployment, and then it stops. We have seen also transmissions that have been stopped unexpectedly. And also another issue is when the satellite doesn't have accurate orbital data. Usually this happens the first days after deployment and during the re-entry of the satellite. In all these problems, we have the SatNOGS network that tries to solve these issues, or at least help and improve the situation. So we have around 287 online stations right now around the world, and also some stations in testing mode that are expected to be online. And let's see now how this works, what is the workflow of the SatNOGS project. So we have the ground stations and the network. The network actually organizes and handles the operations of the ground stations. So we are scheduling observations. One thing is to schedule observations of satellites in the network. So this is the interface. So we choose the satellite, the transmitter, and the stations. We have a start and end time, and then we can choose all of the passes that we want to schedule. And then the ground station asks for the jobs that are scheduled from network, performs the jobs when the satellite is over the ground station, and then sends back the data that gathered from the observation. This data, this is the observation list of the satellite. Actually, it's also okay. And these are results. We get audio, we get the spectrogram, the waterfall, and if there are demodulated data, we also list them in the observation page. Then the data we gather from the ground stations are transferred to SatNOGS DB in order to be stored there. And with third-party observers that also sends data to SatNOGS DB, we create the collection of the data frames of the satellite. And here is the DB information, where we store some info about the satellites, the transmitters, the transmission parameters and tails, and the data, and we also store the orbital data for the satellite. Just to say that all the information we get from the satellites are gathered by a crowdsourced process, so everyone can suggest changes in the satellite TP, and these changes are reviewed and then added into the TP. So this data, when we know how to decode them, we create a decoder, a SatNOGS decoder, using a kite track, which is a description of the frames of the satellite, and with this kite track we can automatically create decoders in different programming languages. We use mostly Python. And with this decoder, we can decode the data and create dashboards like this by using the Grafana software. In parallel, we use SatNOGS network observation and also STRF tools and STRF observations to perform the satellite identification I talked earlier. So here we have the STRF tool that shows this is the expected curve we get for this object, and we see that the signals are following this curve. So we have identified this object and know which satellite is. A similar thing in network observations with a tool that is called Ignos. We get, again, the red line is what we expect to see for the signal to follow, and this is also follow. This is based on the Doppler effect of the signal we get as the satellite passes over the ground stations and transmits. Another thing is the orbit determination and the TLE sets generator. We use again the STRF tools. The process is that we export the frequency and the time of the signals. It's these red dots, as you can see here. And what we try is to get previous TLE, or we create a new TLE. TLE is the two-line elements. It's a set of the parameters actually that describe the orbit of the satellite. So what we try is to get these points and try to fit the parameters to follow these observed transmissions, these observed points. And this way we generate TLE. So this is the whole workflow we follow in SatNOGS. And here are some statistics about the SatNOGS project. So in SatNOGS network we have more than 400 ground stations right now, around 10K observations per day, but this is without utilizing full the network. It's we get also around 70,000 demodulated frames per day, and in total we have more than 12 million observations in the last 10 years that SatNOGS works. In SatNOGS TP we have around 2,000 satellites and 4,000 transmitters. Also, we have gathered until now around 285 million modulated frames from the network and also external observers. And we had like 19,000 suggestions for new satellites, transmitters, or changes for them. And some other tasks, such we have created more than 100 coders and more than 150 dashboards. We have generated 1,000 theory sets, more than 1,000, and we also have done more than 220 satellite identifications. So, how someone can contribute to SatNOGS project? It can build a ground station. The simplest format is just a Raspberry Pi, an SDR device like RTL SDR, and an omnidirectional antenna. Or you can buy SatNOGS kits that has gathered all the components and set it up. Another way to contribute is by developing software or hardware, by adding new features and existing projects, or fix some issues that there are, some bugs, writing tests, and also writing documentation. Finally, you can participate in the operations of the SatNOGS project, so you can add with suggestions content in SatNOGS DB. You can create decoders, build dashboards, schedule observations for special events like deployments or some ice contacts or stuff like that, and also help with the satellite identifications. And that's all. Here are some links for the websites, the wiki, we gather some information, the community forum where we discuss observations or events, sort of things, and our repositories where all the software and hardware